So this video is going to explore the notion of mixed numbers and improper fractions in a little bit more detail. So let's have a look at an example of both. Let's have a look at a mixed number, let's say 3 1/7, and let's have a look at an improper fraction, 17/3. So a mixed number is a mixture of a whole number and a fraction, as you can see. And an improper fraction is where the numerator is bigger than the denominator. And that's all you need to remember about those. That's just the definition of those terms. All right, so the thing I want you to think about when it comes to mixed numbers and improper fractions is that these are essentially both division, right? So these harken back to the work you've done in division. In fact, a mixed number is a division answer. And you'll see what I mean in a moment. And an improper fraction is a division question. Why is it so? As the late Professor Julius Sumner Miller would say. All right, so let's get into what those terms mean in relation to mixed numbers and improper fractions. All right, so the thing I want you to think about is this line here. Its proper name is the vinculum. Okay, that's a good Trivial Pursuit bit of knowledge. You probably won't need to remember that, but that's what it's called. But the vinculum is essentially the division symbol. Okay, so if I write the division symbol, I'm going to write a big division symbol. And if I rewrite this one, this improper fraction, 17/3, what this means is 17 divided by 3. So you think of the division symbol as a kind of fraction, okay? And with the wonders of modern technology, I can show you what I'm talking about. It's 17/3, 17 divided by 3. So it's a division question. And the mixed number is a division answer. All right, so I'm going to take the long way around in explaining all of this. Remember, this is not really how to do them. This is really the concept behind it, in case you really want to understand. So let me represent this number here, 3 1/7. So I'm going to draw 3 1/7. Now remember, it's 3 whole numbers and 1/7. Now because we're dealing with sevenths, the wholes that I'm going to be drawing, that is the full objects, they're all going to be divided up into 7 parts. All right, so there's 3 wholes. So 1, 2, 3, 4, 5, 6, 7. Okay, so that's 3 of those. So there's your 3 whole numbers, right? So if I was doing a fractions illustration, they'd be completely colored in, 3 wholes completely colored in. And there'd be another one of the same size, 1, 2, 3, 4, 5, 6, 7, going slightly off the page. But in that one, only one part would be colored in. So there's your 3, and there's your 1/7, 3 1/7. So that's what it looks like. So that's the whole number and the fraction represented in a diagram. Now, 17/3, if I was representing that as a diagram, I would have a series of thirds. I would have 17 thirds. Well, what does that mean? Well, I'm going to start creating thirds. I'll show you what I'm talking about. So if I draw a shape, it's convenient on the grid paper because I can automatically divide my shape into 3. So there's 1, 2, 3 thirds. Do you get what I'm saying? It's 3 colored in out of 3. So there's 3 thirds. So I'll do another one of those. And there's another 3 thirds, making a total of 6. Getting a bit messy. So that's 9. $12. 15. And now here's where it gets a bit different. 16, 17. All right, do you see that that is 17 thirds coloured in. 3/3, 6/3, 9, 12, 15, 16, 17 over 3. And you can see now what the mixed number is going to be. We'll look at the wholes. 1, 2, 3, 4, 5. 5 whole shapes are coloured in, and 2 of the 6th shape are coloured in. So it becomes 5 2/3. So that's how we that's the concept behind the improper fraction becoming the mixed number. All right, so now we've got the concept of the mixed number, and we've got the concept of the improper fraction. Let's have another look at the mixed number. So let's draw 3 1/7. Because I'm dealing with sevenths, I need to make a shape that has 7 parts, or that's easily divided into 7. 1, 2, 3, 4, 5, 6, 7. Okay, there we go. And I'm going to colour in the whole thing. So that's one whole thing coloured in. Here's my second, and here's my third. The whole thing coloured in. So there's my 3 wholes. Now I need to somehow represent this 1/7. So I'm going to draw another one. And this time I'm only going to colour in one part of the 7 to make 1/7. I will draw these in so that it's easier to see. So hopefully you can see that this is 3 1/7. Now what about if I'm turning that into an improper fraction similar to this one? So now we look at exactly how many sevenths we've got coloured in, right? Each of these is a 7th because it's a shape divided into 7 parts, 7 equal parts. So each of these represents 1/7. So if I look at all the coloured in shapes, how many sevenths altogether have I got coloured in? Well, let's just count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. So, as an improper fraction, it's 22/7. If I was to do this as a division question, 7 into 22, I would have 3 with 1 remainder over 7. And that's why we've been getting you to write your remainders in that format when we do division. Okay, so you can see that this 3 1/7 is the answer to a division question, and you can see what that looks like when it's represented. Now that we've looked at the concept behind the mixed number and the improper fraction, let's go back over the way to do it a little bit more quickly. And again, this is a much easier process if you've got a good handle on your multiplication tables. So let's look at 3 1/7. Remember, this is the answer to a division question. So what would the division question be? Well, division is the reverse of multiplication. So in order to recreate that original question, we're going to use multiplication, all right? So this is the process. You take the denominator and you multiply it by the whole number. Then you add, might change colors, then you add the numerator, which is kind of the remainder. So if I do that process, 7 times 3 is 21, plus 1 is 22, so I get 22/7, and you'll remember that when we did it in a diagram, that's the answer that we got, 22/7, so you can see that that works. If we do another quick example, 4 3/5, for example, maybe you can get ahead of me and figure out what it is. So I'm going to take the denominator, I'm going to multiply it by the whole number, 4 times 5 is 20, and then I'm going to add the numerator, which is 23. So my answer would be, in this case, 23/5. If I turn my attention now to the mixed number, remember what this is saying, in a sense. It's saying 3 into 17, or 17 divided by 3, because remember this line here, the vinculum, is the same line that you see in the division symbol. So what is 17 divided by 3? Well, I can do my 3 times table, but I'm going to slightly do it the long way here. I'm going to sort of count up the 3 times table. 3, 6, 9, 12, 15, 8. No, I can't go to 18. That's too much. So how many have I got? I've got 5. Now 5 only gets us to 15. We need to get to 17. So 15 plus 2 is 17, and the denominator stays the same, 5 2/3, and you'll remember that when we did it using the diagram, that's what we got. Let's do another one very quickly. Just going to clear some space. So what about if we have, I don't know, 36 over 5. Let me just move this guy out of the way. So now we do a division, 36 divided by 5. How many 5s go into 36? So if I know my 5 times table, 5, 10, 15, 20, 25, 30, 35, 4. Now I can't go to 40, so I've got to stick with 35, and that is 7. 7 5s are 35, but the number we want is 36. How do we get to 36 from 35? Well, it's remainder 1 over the denominator stays the same. So 7 1/5. So that's a little bit of a deeper dive into the concept behind mixed numbers and improper fractions. If you can remember the process for doing them, then you really don't necessarily need to understand the concept, but it's always helpful to know the concept because you might be able to apply the principles behind it to later knowledge. Instead of just learning the steps of the dance, you become more the choreographer of the dance. You understand how to create those steps. So there might be some work attached to this video. If there is, have a go at doing the conversions, but really this is just a bit of background as to how the improper fractions and the mixed numbers work in terms of the concept. So good luck, and if you have any issues, as ever, let us know.